Welcome back. In this video, we're going to prove that z given by 1 plus I quantity to the power n plus 1 minus I quantity to the power n is in R. That means is a real number. Or we can prove this one using the exponential form of these two numbers, 1 plus I and 1 minus I. But for us, we just gonna prove it using this theorem that a complex number is real if and only if its conjugate is equal to itself. So in this case, we can simply prove that this result here. Okay, we know that if z is x plus iy, then z bar is x minus iy. So if we equate these two here, we're gonna see that y is 0, and therefore the imaginary part is 0. Therefore, we have only the real part for this number. Okay, so it's an easy result to prove, very easy. Okay, now what we're gonna do here is that we're gonna prove that the conjugate of z is equal to z, and therefore z is real. So here we have z is 1 plus I to the power n plus 1 minus I to the power n. So we have the conjugate of z is 1 plus I to the power n plus 1 minus I to the power n, the conjugate of everything. So the conjugate of two complex number is the sum of the conjugates. So the conjugate of the sum is the sum of the conjugates. Okay, here we're gonna use that. So we have 1 plus I to the power n. We have the conjugate here plus 1 minus I to the power n, the conjugate. Okay, another result that we have is that if we have some complex number, then the conjugate of z to the power n is z to the power n, the conjugate of z to the power n. So we're going to use that one here. So therefore, we're going to have 1 plus I, the conjugate of 1 plus I to the power n plus 1 minus I, the conjugate of that to the power n. Now, what do we know about 1 plus I, the conjugate of that? It's 1 minus I to the power n. Remember that if you have z is x plus iy, then its conjugate is just x minus iy. Okay, so we put a minus in front of the I, we put a minus in front of the imaginary part. The imaginary part is 1 here. We put a minus, so we get minus I. Here, the same thing here. If we put a minus here, we're gonna get a plus I to the power n. So if we compare this one with this one, we see that this is, so z bar is just z. And that means that z bar is z, and therefore, according to this result here, so z is real if and only if z is equal to z bar. Okay, this means that we get z bar is z, therefore z is real. Okay, that means we have proved that this complex number is a real number. Okay, another way that we can do to prove this result is note that we can show that 1 plus I in its exponential form is square root of 2 ei pi over 4, and 1 minus I is the square root of 2 e to minus I pi over 4. And once we do the n power, we're just gonna get square root of 2 to the power n e to minus I n pi over 4. And here we're gonna get 1 plus I to the power n is square root of 2 to the power n e to I n pi over 4. If we add these two, we're gonna have, if we add this one with this one, we're gonna have the square root of 2 to the power n times e to n pi over 4 plus e to minus n pi over 4. We divide by 2 and we multiply by 2, and we're gonna get z is gonna be the square root of 2 times n times 2 times e to n pi over 4 plus e to minus n pi over 4 over 2. And according to Euler's formula, this is just the cosine of n pi over 4. And what can we conclude here? This is a real This is a real, and the product of two real numbers is real. Therefore, this number is in R. This is another way of proving the result. Okay, if you see any errors or any mistakes, please let me know. Thank you very much.